Hey guys, welcome back. If you've been watching the series on data structures in Python, so far we've covered arrays, stacks, queues, and linked lists. Today we're moving on to a slightly more complex data structure called a hash table. Let's talk about why a hash table is important, and later we'll see how to actually implement it. So why should we care about hash tables? Well, number one, they're highly efficient at storing and retrieving data. You might have already used a hash table without knowing it if you've ever used a dictionary in Python. And number two, you may need to implement one from scratch in an interview. In fact, Google's official interview guide states that hash tables are arguably the single most important data structure known to mankind. You should know how they work, be able to implement one using only arrays in your favorite language in about the space of one interview. Let's look at an example of a hash table, and then we'll implement one using Python. Okay, so here we have 4 friends: Sophia, Dorothy, Blanche, and Rose. We also have their ages. We need a way to store this in a data structure where we can essentially query the data structure. So for example, we can ask it, how old is Dorothy? And our data structure should quickly go to that name in memory and return the age that maps to that name. So this is how we can implement that. The first thing with a hash table is we need to decide how much space to allocate towards it. We'll see why that decision is important later. For now, we can assume that our data set is small, so we only need a small amount of space. Okay, we've instantiated our hash table and it has 6 buckets to store our data. Let's start with rows. How do we decide which bucket to store rows? Well, let's assume that our hash table has some magic method that will tell us exactly which bucket to place rows into. So we send rows into this method, and the method says, rows belongs in bucket 5. We do the same with all of our friends, and now our hash table contains all of the data that we need. Now we can ask the same question as before, how old is Dorothy? And our hash map retrieval function does the same thing it did when it stored Dorothy. It passes her name through the magic function, and it tells us exactly which bucket to go to. We go directly to that bucket, find Dorothy's name, and return her age, which is 55. At this point, you might be wondering what happens when the hash table isn't big enough to hold all of our data. In this case, our hash table has a size of 1, so we end up mapping all of our values to this one bucket. This is called a collision. When we have a collision, we can simply chain the values together in an array or a linked list. This is a good solution, but keep in mind that too many collisions will change the time complexity of the hash table. Instead of being able to look up a value in O of 1 time, we now have to search through each item in a bucket to retrieve what we're looking for. Okay, so let's see how this all works when we write our own hash table class from scratch. So earlier I mentioned that we needed some kind of magic method that would take a string like the name Dorothy and return the index of the bucket that we need Dorothy to map to. We're going to call that our hashing function. Now this is a bad example of a hashing function. Regardless of what we pass into it, we always return the same index. So let's improve this. One common way that we can create a semi-unique number based on a given string is to sum up the values of all of the characters in that string. So to do that, we'll loop through the string and we'll add the character code onto our hash. Now if we just return the hash, the results are too large. We only have 10 buckets available. So now what we can do is find the remainder of the hash divided by the number of buckets available. And now we can see that the string Dorothy maps to 7, Rose to 1, Sophia to 4, and Blanche also maps to 7, so this is an example of a collision. If we want to improve on this hashing function even more to reduce the possibility of a collision like this, we can also look at where each character is placed in the string. Let's see an example where we have 3 different strings, but they all have the same characters. They all end up mapping to the same index. So let's change this for loop. So let's try taking the value of that character and multiplying it based on where it's located in that string. Now we can see that even though all 3 strings have the same characters, they map to different indices. So now let's see if we've eliminated this collision. And it looks like we have. Alright, so now we're ready to define our hash table class. Our hashing function will now be a method on the class, and we'll move num_buckets to self.size. And we'll initialize the table as an array of arrays. So each array within the bigger array represents a bucket. Now let's define a function that will take a key value pair and add it into our hash table. Now let's call our hashing function to get the index of the proper bucket. We find that correct bucket and we append that key value pair to the end of it. Next, we need a way to retrieve our key value pairs. So let's do the same thing as before. Let's call our hashing function in order to find the correct index of the bucket. So all we need to do now is loop through the values in that bucket to find what we're looking for. If we find a match, we can return the value. Otherwise, we'll return none. Okay, so now that we have our functions that will add and retrieve values from our hash table, I'm going to add in this boilerplate code that will help us visualize the hash table when we print it. And all this is doing really is printing out each individual bucket with the index of the bucket and arrows joining each of the key value pairs in the bucket. So let's go ahead and create our hash table and start adding values. And now when we print it out, we can see each bucket and the key value pairs that that bucket holds. The last thing we can do is answer our question from earlier. So we can say, how old is Dorothy, by calling our .get function. And when we print the result, we get the expected answer. So that about covers it for hash tables. If you like this video, please feel free to give it a thumbs up and subscribe. And if you have any questions, feel free to leave a comment. And thank you so much for watching, and I'll see you next time.